guys, my name is Niranjanes. I am currently pursuing in Sri Venkateshwara College of Engineering, Bangalore. My USN is 1VE23CY033, subject TDCO, subject code BCS302, topic concept of K-map and its advantages and disadvantages. Now, introduction to K-map. K-map are a graphical method used to specify Boolean expressions. They help in minimizing the number of logic gates required to implement a Boolean function, which is essential for effective circuit design. Boolean algebra and K-map. K-map rely on Boolean algebra, which is a system of representing logical operations using variables and operators like and, or, and not. K-map provide a visual way to understand and simplify Boolean expressions delivered from truth table. Boolean algebra, the fundamental mathematical framework behind K-map, it allows for representing logic operations using variable and operators. A graphical representation of Boolean expression that enables specification by identifying adjustment groups of. Once again, K-map representation. A K-map is grid-like representation of a truth table. Each cell in the K-map corresponds to a unique combination of input variables. The value in the cell represents the output of the function for those input combinations, like rows and columns and cell values. Now, rows and columns represents combination of input variables, ensuring adjacent cells differ by only one variable. Cell values. Cells are filled with 1 or 0 based on the output of the function of corresponding input combinations. Specification using K-map. Simplifying Boolean expression using K-map involves grouping adjacent cells containing ones. The groups should be as large as possible for regulate or rectangular or square shapes. Grouping. Identifying adjacent cell with ones and group them in the largest possible rectangles or squares. Minimization. Each group represents a simplified product term and the final simplified expressions in the sum of these product terms. Advantages of K-map. K-map provides several advantages and traditional algebraic simplification methods. They offer a visual approach, making the process easier to understand and implement. Simplicity offers a visual and intuitive way to simplify Boolean expressions, eliminate complex algebraic manipulations. Efficiency leads to minimized expressions requiring fewer logical gates, which translates to reduced circuit complexity and cost. Clarity provides a clear and organized representation Boolean expression, making it easier to identify and implement optimal solution. Limitations of K-maps. While K-map are powerful tools, they have limitations as the number of input variable increases, the size of the complexity of the K-map grows specifically. Complexity. K-map become difficult to manage with a large number of input variables. Don't cares. Handling don't care condition where output doesn't matter can be Challenging with K-maps. K-map disadvantages. Limited stability. K-map become complex as the number of input variables grow, making them impractical for large circuit. Don't care conditions. Dealing with don't care conditions can be challenging and may require additional effort to optimize the resulting expression. Limited flexibility. K-maps are primarily suited for minimizing some of the products and the products of some expression, limiting their applications to others type of Boolean expressions. Applications of K-map. K-map have widespread applications in digital circuit design, computer architecture and control system. They are used for simplifying logical expressions which are crucial for optimizing the design and performance of the system. Digital circuits. Simplifying logical expressions for digital circuits, reducing the number of gates needed. Computer architecture. Optimizing control logic in CPUs and other hardware components. Control system. Simplifying logic for controlling various systems like traffic lights and industry process. Conclusions and summary. K-maps are essential tools for simplifying Boolean expressions. They provide a visual and efficient method for optimizing logical circuits, leading to reduce complexity and improve the performance in various applications. Boolean algebra foundation. K-map are based on Boolean algebra, which represents logic operations using variables and operators. Graphical simplification. K-maps offer a visual approach to simplify Boolean expressions, minimizing the number of logical gates. Wide applicability. They have numerous applications in digital circuits, computer architecture, and control system.